Welcome to the fifth industrial revolution. My name is Ruchin Kansal. I'm the director for the Center for Leadership Development at Seton Hall University and also a faculty member with its Department of Management, where I teach a graduate level course by the same name. If we look out into our world, we see three, if not many, of course many, but three major trends. One, the climate crisis and the changing condition of planet Earth. Everyone is talking about rising sea levels. Everyone is talking about, the challenge we will have in terms of resources, et cetera, et cetera. And of course, technology is playing a big role in terms of will we as humans be able to find work, or will we become fungible and replaceable? So that is one big trend that everyone is focused on and thinking about. The other big trend is this exploration of space. Every day we are talking more about going into space. The first space hotel in 2027 feels like the excitement of the aviation industry 100 years ago, where we are on the precipice of something really exciting, and once it happens, it will just be routine for all of us. $1 trillion, if not more, industry. And if we really look at both of these and look at where these may intersect in terms of humans, human bodies are neither adept to changing climate conditions on Earth, nor are they adept to living in space. And we are seeing a lot of innovation in health technology that can actually allow humans to adapt to these conditions without the Darwinian adoption of our bodies. Is that going to be the fifth industrial revolution? So those are some of the questions that we start with as we try to explore where we might end up in the future. Of course, helping me in my effort are two of my students, Anthony Pizzoni and Tillman Pitcher. And today, it is a great pleasure to have Dr. Michael Lembeck joining us. Dr. Lembeck is a professor at University of Illinois, Urbana-Champaign in their Department of Aerospace Engineering. A space systems expert, he has been involved in many groundbreaking projects, and I'm going to read here for a second. He has worked on Jupiter Orbiter, Space Industries Wake Shield Facility, Orbital Sciences OrbView Warfighter Commercial Remote Sensing Program, and also the Northrop Boeing CEV and Boeing Commercial Crew Programs. He was part of formulation of President Bush, is a vision for space future, and also developed the requirements for Constellation Orion Program. Dr. Lembeck, it's really, really a privilege to have you with such great background and work in this space. So for purposes of our audience, why don't you introduce yourself? I'm sure you'll do a much better job than I did. Just talk to us about your background and how you got interested in this space.
Thanks very much. You did a fine job. I have got about 40 years of experience in government and industry. And about 3 years ago, decided to give back a little bit. So landed here at Illinois, close to my original home where I grew up. And it's been a lot of fun sort of working with the students here to actually try to undo the 60 years or so of inertia that have built up in aerospace engineering.
Yeah.
Once we figured out how to do things right, we don't want to let go of that because of the risks involved. And so it kind of stifles innovation. And that's one of the things I've tried to tackle here, is to figure out how to teach that innovation while also accommodating the fact that we have humans involved typically in a number of spaceflight missions, and how do we protect them as well.
That's very interesting. You talk about this whole idea of inertia in because we have figured something out that works. We don't want to really break from that and explore the new. A lot of times it's also driven by where do we want to go, right? And I know you worked with President Bush on his vision. What's our vision? I mean, where are we trying to go with the aerospace and space in particular?
Well, I think we're at a unique time. Typically the space program goals and objectives change with each incoming administration. And we've been fortunate now with President Bush. He basically came to NASA headquarters one day and said, I don't know what you guys are doing. Where are you going? And that was the start of the vision for space exploration, where we laid out a plan to return to the moon, gain some operational experience. After all, most of the NASA population is starting to get near retirement age. And so we need to relearn some things. A lot of the Apollo folks are long gone. So to relearn those operational things that would need to work and operate in space. And as part of that, the moon is very conveniently 3 days away. So the logistics trail isn't quite as bad as it will be for Mars, which is 6 to 18 months away. I always like to say too that space is an ocean, and you're not going to cross the ocean in a rowboat. And so the technologies we have today are still in that rowboat phase, and we're going to need to develop some new and innovative means of getting away from the moon and onto Mars and the outer solar system. Something new and fast is going to be required.
So is that where the focus of aerospace engineering is right now? That new and innovative technology and how it will take us beyond, let's say, the lower Earth orbit. I know we have flown the helicopter on Mars, we have the rovers on Mars, but I mean, if you can really talk to us about the mega trends in aerospace engineering and the kind of problems you're trying to solve for.
Well, I think there are 3 mega trends today that aerospace engineering is really tackling. The first one is directed simply at cost, and that is reusability. We see reusability across the board now. The Falcon 9 rocket has flown over 100 times successfully, has not had a failure. And you get the rocket back and you refill it with some gas, which is just a small increment of cost over the original manufacturer of the rocket. And so you are able to quickly reduce the cost of access to space to do good things up there. And at the same time, you're generating profits that you can invest in future technologies. So if we look at a company like SpaceX, Elon may charge 50, 60 million for a rocket launch, but he's only putting about $300,000 worth of gas in each rocket he reflies. So he can kind of take those that revenue and move it forward to pay for things like Starship. So reusability is going to be key to bringing those costs down. We see Blue Origin, ULA, and others attacking the problem from that point of view. I think the second mega trend is miniaturization. The less stuff you have to put into orbit, the cheaper it is, of course. And as we miniaturize capability and functionality, things like CubeSats, which just 1997 got their start with the first one, and now today we're seeing upwards of 3,000 to 4,000 satellite constellations being built. And they have a lot of capability, and that's coming about because of the miniaturization of components, bringing the mass down, bringing the power requirements down, and increasing the actual functionality is a big trend I think we see going forward. And I think the third mega trend is automation, artificial intelligence, machine learning, applying that to reduce the costs of the standing army that we keep on the ground. If you recall when the space shuttle flew, and even today supporting the space station, you have a standing army of people down in Houston that are there 24/7, watching the vehicles, watching over the astronauts as they work. There's another group of ground controllers over in Russia. Those people have to be paid, and that's rather expensive to be able to carry on an expedition like we do on the space station. So by automating some of that functionality, being able to take people out of the loop, we again reduce the cost of access so that we can put our resources into things that actually add exploration value, if you will, being able to go out, explore, find new things. And that's, I think, what space exploration is about, and at its root.
You bring up 2 very, very interesting points, right? When you talked about reduction in cost and usability, can you give our audience a little bit of a sense of 1970s and today? How much did it cost to send a pound of material into space, in the 70s versus how much might it cost today?
Going back to the 70s is kind of hard because there were so many government subsidies. It was, really difficult to put your finger on it. Sure. I've heard numbers quoted on the order of $50,000 a pound to $20,000 a pound, sort of thing. Mm-hmm. Elon Musk just the other night gave a review of his Starship rocket, where he said he was going to be launching 150 metric tons into space for potentially $1 million. That's just a phenomenal price cut if he can achieve that.
Yeah, yeah. Well, I'm just writing here. So that's very interesting. So we have significantly reduced the cost of sending stuff into space, and we all know that as cost goes down, innovation does increase, and then there's a lot more exploration that happens. The other thing that was very interesting in when you were defining megatrends was the third one, when you talked about reducing the ground army, right?
Right.
And so it is a little bit counterintuitive, and maybe it is not. But you talked about how AI, etc., could replace the need for humans managing space flight. When I started our session, I talked about how technology is making humans fungible. So how do you kind of, bring that together? I mean, is space exploration purely about exploration and maybe making life better on Earth and maybe space mining, or is it about finding more to do for humans out there?
A little bit of both, I think.
Mm.
We certainly, if you look at, say, the Mars rover Perseverance,
Yeah.
as of today, it's been on the ground now for 1 year.
Mm-hmm.
It has covered, I'm not sure exactly how far, but it's not been more than 20 kilometers or so of distance. It's been moving around in that time period. And if you go back to Apollo 15, when the first lunar rover was carried up by the lunar lander and used by the astronauts on the moon, they probably covered at least that same distance in 3 days, probably more.
Mm.
So while automation is getting better, it still can't do what humans do in a lot of cases today. And consequently, putting humans on the vehicle to go out to do the exploration is really important. Another example is where AI excels today is in doing identification of different kinds of objects.
Mm-hmm.
You can train it to tell the difference between a horse and a rabbit and a cow. But if you throw in there a system that's been trained on those three things, if you throw a car into it, it will try to mischaracterize it maybe as a cow. It cannot do anomaly detection very well. And that is really the focus of exploration, is to go out and look for the anomalous situations, conditions, environments where you're going to have a discovery. And so AI has a way to go yet. And that's one of the things we're working on in my lab is anomaly detection in a neural network, and seeing how we can go about either augmenting humans in their missions of exploration, or being able to go into more dangerous situations, austere environments and such with robotics, so that we don't put the human at risk. The human can step back and operate the system, but the system needs some level of autonomy so that we don't get back to the standing army situation.
Great. So that makes sense, right? Making the technology autonomous enough that it can go and explore and maybe make way for humans to go there. So I'll just say this. When I was teaching the graduate class last semester, broadly speaking, 3 areas emerged as potential areas of space exploration. One was, space tourism. Basically, we go out there, we live in space hotels, we orbit around, we come back, we are all happy, and it's great. The second one that emerged was, yes, it is a way to extend our resources, and space mining is going to be the near-term future. And then the third one was that we will have to leave Earth, and this was the most far-fetched scenario, that we will have to leave Earth and settle in space. Now, as you are looking at this autonomous exploration of space, do you think that way, or how do you even think about exploration? What's the objective of that?
Well, I think exploration is, right now, in terms of the U.S. program's focus, is to go see if life existed elsewhere. We started by following the water to Mars. Now we're trying to get down and see, is there certain environments, either under the surface, under a rock, or in the past, where life existed. And so that's probably going to be the focus of exploration for a while. Further out, at Europa, Ganymede, there are water oceans out there. Will we find something? Of course, those are very high radiation environments around Jupiter, so it's going to be difficult for humans to go directly. And automation and AI are going to support those explorations out there. But in the end, I once led a debate when I was at NASA headquarters on NPR between a couple of professors. And one professor was debating the need for humans, the other one debating the use of robotics. And so the one that was promoting robotics, I asked him if it came time to go on vacation, do you just go to your computer, pull up a web browser and look at pretty pictures of the Caribbean or Europe or wherever you want to go? Or do you really want to go there and experience it firsthand? You know, smell the smells, see the sights, taste the food. And I think that's innate in humans, that we want to go there and experience it for ourselves. And that's all it's going to be. And so I think humans will always be part of the exploration scene as we go deeper into space.
Yeah, and then we have had that debate on this channel as well. And mostly we land in the same place, that technology is a tool that will allow us to explore and get into these environments, but ultimately it is for our ability to be able to, smell it, sense it, live it, that we are doing it. So, I think there is a very good alignment there. And then you talked a lot about your work in AI in your lab, and how that can help with anomaly detection. You also talk a lot about fuzzy logic. So can you break down fuzzy logic for us? What does it mean to a sixth grader or a fifth grader? And then how is it being applied in the field of space exploration?
Well, it turns out that fuzzy logic was one of the first implementations of so-called artificial intelligence, usually applied to control systems that were very not well defined. In the case of my application, I worked for one of the earliest little commercial space companies that existed, called Space Industries in Houston. Max Vauget, who was the father of the American space program, designed Mercury, Gemini, Apollo, and the shuttle, retired from NASA and started this company. And one of the products we had was a refrigerator incubator that was being designed to fly in the shuttle, flew on just about every shuttle flight after STS-49. I believe there are a couple on the space station today. And one of the original boxes is actually in the Smithsonian Institute now, the Aviation Institute out there. So we had this problem where we had to fly things that would include maybe metal plates or maybe large tubs of liquid, which would have very vastly different thermal properties. And we didn't know a priori everything that we'd fly, and we didn't know, we didn't want to have the astronauts have to tune the gains on the control system every time. So with fuzzy logic, we were able to provide an algorithm that would sense the temperature data coming from 10 thermistors that was arrayed across the payload. And with those 10 thermistors, it would try to identify, characterize the thermal properties of the payload it was dealing with, and then develop a control. And it, in fact, was able to hold temperature of anything that you would put in there, regardless of its thermal characteristics, within 1/10 of a degree. And that was enabling for a lot of research that was done on the space shuttle that involved protein crystal growth. In 0G, there's no convective currents in liquids because of gravity is lacking. And so by putting these protein crystals in the incubator, we would be able to allow them to grow to sizes that are much larger than can be obtained here on Earth, because on Earth, convective forces break them up. And then once they grew to those sizes, we would chill them inside the refrigerator and bring them down to Earth so they'd be solidified. And then they could go through a characterization here on Earth, microscopic characterization, to determine their structure. So we learned a lot about protein crystal growth, structures. There were other things, other material properties, experiments that were performed. I think we flew a lot of bacteria, salmonella, HIV, and things like that to do studies on. So this box with fuzzy logic was actually enabling, took the astronaut out of the loop. All they had to do is push a button to start it. They didn't have to, and we didn't have to do anything either. So it is actually, from a commercial space point of view, it took a bunch of humans out of the loop and a bunch of control system designers. They didn't have to come together every time we flew a new payload. They could just let the thing do the job itself.
Right. So essentially, you put in a certain algorithm into the box based on a certain logical outcome you were looking for, and that a good way to define fuzzy logic?
Yeah, it's kind of I think the way we as humans approach some control problems we don't know anything about. Let's say you're trying to, you just bought a brand new television set.
Mm-hmm.
You don't really understand how much of the knob you've got to turn the volume up.
Yeah.
And you don't want to blast everybody out the first time you use it.
Mm-hmm.
So you kind of go in and you apply a little bit of twist, and the volume comes up and a little bit more, and you finally realize how much twist per volume you're applying.
Yeah.
Same thing with fuzzy logic. It works in terms of qualitative measurements, and it will twist it a little bit and a little bit more, and it'll try to define the characteristics of the systems it's dealing with. And then, and basically the language of fuzzy logic is just that, a little bit more, a lot bit more. And by creating those kind of control laws, it can figure out and do the job that you ask it to do.
Yeah, and no wonder that's why we call it artificial intelligence, because we are almost simulating the way humans think in technology, and therefore the term fuzzy logic makes a lot of sense. So, we talked about artificial intelligence and then fuzzy logic and how we are designing these systems to really learn as they're out there. I also have heard a number, and you can correct me if I'm wrong, but so far we have only sent about 600 people into space.
Right.
Is there a plan to send many more in the future? And if yes, how are we planning to do that? Because I mean, we as humans, we need food, we need systems to be able to conduct all our bodily functions. We need to maintain our mental health. So is there a lot of work going on in understanding how we can send humans into space, and then will that number increase slowly or exponentially in your view?
Well, I'm going to argue exponentially, because I just heard the statistic today that with the advent of commercial space and the astronauts that have been flying on Virgin Galactic and Blue Origin, we now have created more astronauts in the past year than NASA has in the past year, commercial astronauts. So I think we're going to see space tourism really ramp up. Now, granted, these are suborbital flights for now.
Yeah.
But we've already had one orbital flight with the Inspiration 4 crew, and the same billionaire just recently bought 4 more flights on the Falcon.
Yeah.
So I think we're going to see more of that. There's other folks out there waiting to take the trip. And of course, we do have to provide a living environment for those people. Food, water, air, all of that. If the mission's short, you carry it up in tanks and buckets and soft bags. If the mission's long, you have to develop recyclable systems that can purify the air, replenish the water, and so forth. A lot of that technology development is currently happening on the space station today. And eventually, when we go to Mars and beyond, we'll also have to start to live off the land.
Yeah.
Taking advantage of the in situ resources that are there as well.
Mm-hmm. And so is that, who studies that? Is it aerospace engineering students? Who is studying that, or is it really interdisciplinary?
It's interdisciplinary to an extent, because when you're dealing with systems of that type, you have mechanical parts, you have electrical control systems, you have software running in the computers. So it's interdisciplinary that way. But by example, today, I have a group of students that are working on an extracurricular activity for a NASA program called Rascal. They've been chartered with identifying ways of producing propellant on Mars from some of the glacial water that exists below the surface there. So they first thing they did was turn to Earth-based technologies. And if you go to the South Pole and Antarctica or up in Alaska, you'll find that folks living off the land there produce something called a Rodriguez well. And that's simply dropping a heater down into a hole where there's a lot of water ice, melting that and extracting it out and using it for potable water, or with solar power, using electrolysis to separate into the constituent parts, hydrogen and oxygen, which of course also makes up rocket fuel.
Mm-hmm.
So I think, there's multiple groups like that today. NASA sponsors, competitions to see what's the best way to approach that. In the universities, we have a number of faculty that will be looking at how you put together these systems in an optimal fashion. And just, being able to extract water is one thing. The other thing is, how do you get all that equipment there to make it?
Yeah. And so is it going to be led by America, or do you see Russia and Europe, Japan, China, India playing a big role in space exploration as well?
I think it's going to be a multinational event. I don't believe any one country can go it alone, because right now, any place beyond low Earth orbit is rather expensive to get to.
Yeah.
I think that's a good thing too, because space exploration is one outcome, but the United States, in our NASA charters, we also want to protect our national security interests, the economy, and things like that. So when we send people to the moon, we're, I think, going to actually develop an economy there. If I like to use the example of Lembeck's Pub. If I had a bar on the moon, and you come in and buy a beer from me, you're going to put a couple of dollars down on the table. Eventually my bar gets dirty, so I'm going to need to clean it. I've got to get the paper towel from somewhere, so I'm going to go down to the local Lunar Walmart, pick up some paper towel. The person there who stocks the paper towel on the shelves will make a salary, and they're not working 24 hours a day, so eventually they want to see a movie. They'll go down to the movie theater with what they made, and pretty soon you have an economy growing. You have international participation and exchange of goods, much like we do here on Earth. And all of that promotes national security for all involved. So I think we'll see the development that took place in the inland United States in the 1800s replicate themselves again and again on the moon and on Mars and other places further out.
You've been in this field, like I said, for 40 years. If given a chance, would you go and live on moon today?
Tomorrow, let's go.
Why?
Absolutely.
Why? I mean, why would you leave the comfortable life on Earth where, there's food, there's water, there's social networks, and go to an alien place where there's nothing and build a life there?
Well, it's like I said, I can look at pictures of the moon all day, but that's not really the experience. And I would like to experience that for myself, see how it's different, how I'm emotionally connected to it, be able to bring those stories back home and share them, and maybe inspire the next generation with what I've learned there. So it's just been in my blood since I was a kid. My dad was a newspaper editor growing up, and he would bring home the stories of astronauts going into space, onto the moon, and so forth. And from an early age, I was hooked, and still want to do it today.
Yeah. And that's very interesting. I mean, right now, what we are seeing is certainly, on the commercial side, at least, the people who are going out there are people who have the financial ability. But as we talked about the reducing cost, I'm also hopeful that the cost comes down enough that I am able to afford at least a lower Earth orbit space flight, if not a flight to the moon, in my lifetime. Because yes, it is so exciting, and humans are explorers, and that's our second nature. So they'll be good. Now, switching topics, and it's totally fair if you don't have a lot of insight into this, but health technology, how do you see people, do you see a lot of work in health technology focused on space exploration? And if yes, where do you see that?
Absolutely. One of the last jobs I had out in industry was with KBR Wiley. They're a company in Houston that trains the astronauts out for their well-being, provides nutritional support, psychological support, even works with the families while their astronaut fathers or mothers are away on a deployment. And in that case, I learned a lot about space medicine. I also participate yearly in the Rice University Baker Institute International Space Medicine Summit. George Abbey sponsors that every year.
Yeah.
And it's intriguing to hear from not only American flight directors and flight surgeons, but the Russians have participated in the past as well. And their approach to space medicine differs a little bit from ours, as you might imagine. But the technologies that are required to keep a human alive in zero G also have some benefits to us here on the ground.
Mm-hmm.
One of the things we've learned from long duration space flight is that your bones start to decay if they're not provided with a load like we get from gravity.
Yeah. So
the astronauts have to exercise, 2 hours a day in order to keep that up. In order to keep those bones from decaying, we've also looked for medicinal mitigations, and some of that has now been applied to osteoporosis here on Earth. So that's been a spin-off, if you will, from learning that. We've learned that fluids don't get pulled down into your body. They tend to rise and collect in your chest cavity and behind your eyes. That creates issues for astronauts. And so the whole program is constantly looking for mitigations for that zero G issues that come up. I tell my students that that's well and good, but I still think the right answer is to keep the human body in the environment with which it is accustomed to. And at some point in the future, we need to go to artificial gravity systems for transportation. And one of the big reasons for going back to the moon as well will be to find out if there's a G threshold where some of these issues go away at. So of course, the moon is 1/6 gravity. Yeah. Is that enough to pull fluids down and allow you to accommodate and not have these problems that we have in zero G? Or will 3/8 G at Mars be good enough? And eventually, people are going to be wanting to go back and forth between Moon, Mars, and Earth, between those different G fields. So we may need some medicinal mitigations for that as well, to be able to accommodate moving between G fields. So it's going to play a large role. It has significantly over the last 30 years in exploration.
So you talk about artificial gravity. How do you create artificial gravity? This is something that sounds so, foreign. How do you create artificial gravity?
Well, the most traditional way that we probably or think about a lot is if you've seen 2001: A Space Odyssey.
Yeah.
You have a large rotating structure, and the centrifugal force causes you to be planted against the outside wall that stops you from flying away from the center about which you're rotating. So taking two masses at the end of a tether, say, and spinning them up will allow you to create gravity. The challenge there is for a short diameter tether, the gravity gradient from your feet to your head can be rather steep.
Mm-hmm.
So you need rather long tethers, large bodies that are rotating in order for you not to have zero G at your feet, right, and G at your head.
Right.
That'll be a challenge.
And then, so I'm assuming a lot of work is being done in this space as well.
Yes.
Artificial gravity.
I think that and the other thing that we really have to worry about as humans from a medicinal point of view is, or health point of view, is radiation.
Yes.
The radiation environment between here and Mars is, to use the word, deadly. And to be able to go there on chemical rockets, we're going to incur large doses of radiation to the point where you wonder if you're going to be able to do reasonable work when you get there. And can you even survive coming back to Earth without getting cancer? So, of course, working those problems, either finding solutions for radiation damage directly, or shielding to keep that from happening, or higher speed transportation, just to beat the rap, if you will. Those will all be important in the future.
Wonderful, wonderful. Anthony Tillman, what's coming to your mind?
Yeah, so Dr. Lembeck, first and foremost, thank you very much for making an appearance on the show. I think I could speak for the whole team when I say that. Today was extremely informative, but one of the things that I wanted to kind of ask you about, because throughout this sort of discussion, you've sort of made note that it's an extremely cooperative field from a geopolitical perspective. It sounds like, based on what you're saying, that the U.S. is really collaborating with scientists and astronauts from different countries. And I was just wondering now, would you say it's more an atmosphere of cooperation or competition? And if so, do you foresee that eventually evolving into a competition for innovation pretty much among countries?
Yeah, that's a good question, Anthony. And I think we're going to have a little more insight within the next couple of weeks. Right now, of course, the Russians and the Americans get along very well on the space station. There's no doubt about that. They share experiences there. They've worked together. What happens if something goes awry in the Ukraine? I don't think we know yet, and we don't know how NASA is going to respond or how the Russians will respond either. We have that third party out there, China, which we do not work with because their program principally is a military program. So that you consider that competitive. Consider right now the Russian program cooperative. I think we have flavors of both, and it'll be interesting to see when we go on to the moon and we establish a base. The Europeans have talked about the moon village, where countries from around our globe will go and live and work together. So the future's cautionarily bright, but I don't think we have the answer yet on how it's going to end up, at least in the near term.
Yeah, and just to follow that up a little bit as well, again, so you spent so much time at the federal organization, NASA. Were those palpable concerns at all during the Bush administration or when you were at NASA? Like, were those geopolitical tensions cause for concern?
Sure. Well, I mean, if you go back to the Clinton era, the space station was really the result of a diplomatic initiative to bring the Russians and Americans together on orbit to try to solve, and even go back further to the Apollo-Soyuz test program, to link up in space and shake hands. That dropped a lot of tension. We learned how to live and work together in orbit, which is in a very austere, dangerous environment. We should be able to live and work better on the ground. It's just unfortunate that the cosmonauts aren't picked up by the diplomatic corps and provide more feedback for the administration over there.
Thanks a lot, Professor.
Also, thank you very much for coming on. The one thing I wanted to talk about, as we're talking about moon villages and such, so the Lunar Gateway that's supposed to get the ball going here soon. I see an article posted just a couple weeks ago that Artemis 1 is supposed to be going sometime in the summer. That's what they seem to think right now. So as far as the moon village, right, which is, from what I understand, mostly a conversation at this point, how do you see this Lunar Gateway, and when it eventually does come into place? I think they say 2024 is their goal to start the actual process. Artemis 2 is supposed to go in 2024. How do you think that all plays into it? And do you think that this is the next big step to getting people back on the moon? I basically just want to hear your thoughts on it, because to me, it's the most exciting thing happening in space right now.
Hate to be a contrarian, but I don't believe the Gateway will survive in the architecture. The Gateway is there right now because the Orion vehicle requirements were put together such that Orion actually has less propulsive capability than Apollo had. Consequently, it can get into a high lunar orbit, but it can't get down to the low lunar orbit where you would separate from a lander to get to the surface and recover it to come home. So the Gateway is there as an intermediate vehicle to work with Orion and the lander together, lower their orbits so that one can get down to the surface, and then when it comes back, raise the orbit so Orion can get home. It has a secondary purpose, which I think is more noble, in that it could serve as the gateway for, say, samples coming back from Mars. I don't know about you guys, but after going through COVID these last 2 years, I don't want anything coming back through the Earth's atmosphere from Mars until we absolutely are certain that it's totally inert. So having somewhere in between to stop and do that examination is certainly high on my list. But as an architectural element, I just don't see that it is going to survive, particularly if you look at Starship and its capabilities to go direct to the surface and ascend from it to come home. It doesn't need the Gateway. And in fact, for the first, Artemis 4 and Artemis 5, which would be the first surface missions, they do not require the Gateway, and the Gateway won't be there. That work is going to be done independent of Gateway to get down to the surface. So as a cost savings, I think I could see forward enough to say that it's going to be hard to rationalize keeping the gateway in place. And after Elon flies, for that matter, it's going to be hard to keep SLS in place.
Hmm. Hmm.
$1 million rocket with more capability than a $2 billion rocket sure is going to gather some attention, I think, from the policymakers.
Absolutely, yeah. Certainly, if you can, like you were saying, bring the cost down, make it repetitive, and get there easy and come out, why not? And that's what Musk is doing right now. But this has been very helpful. What have you missed? What should we have asked you?
Well, I guess one thing I could talk about that I've done a lot of work in and some studies is low Earth orbit, and if we're going to commercialize that. Right now, we're seeing tourism. That's probably real.
Yeah.
But what about using it for manufacturing? And I think you opened our conversation with talking about resources from asteroids and so forth, bringing them back here. And I think one of the things that's been misunderstood is just the low Earth orbit environment and what it is useful for. And it turns out when you look into it deeply, I'll give you one example. Let's say you had a Dragon capsule. Dragons can carry about 3,000 pounds or kilograms rather, round trip to the space station and back. And let's say you filled up the Dragon with lead, which a couple of weeks ago was about $2.50 a kilogram. And you fly to the station and you meet Merlin the magician there, and he's able to magically turn the lead into gold and bring that gold back down, and you sell it. How much money do you think you're going to make after expenses on that round trip?
Yeah, I mean, if lead is $2.50 a kilo of gold, is going to be what, 1.8 million approximately. It's no 28 grams is $1,800. So yeah, I can't do the math very quickly here, right? But it's 30. Yeah, that's a lot of money.
Yeah, well, I'll tell you, it is a lot of money that you're going to make, but you're still going to be in the hole over $30 million at the end of the trip after you paid for the ride.
After paying for the ride.
So the things you're going to make in low Earth orbit have to be more valuable than a precious metal, is my point. And there are only a few things I think that come to that bar. One of them is pharmaceuticals. There are some pharmaceuticals that, of course, will have extreme value if they can cure disease. Another object that we found is fiber optics. Pure fiber optics that allow signals to travel at extraordinary speeds are very interesting to the traders that are doing these microburst trades, at exceptional speeds, just to hit the market on millisecond time. So that 3 kilometers of cable, fiber optic cable, might cost you $1 million. That's very valuable to those folks. But beyond those two things, in the studies that we've done, we can't find much more that would do that. The other thing is, if we bring back a large asteroid, you would think, well, it's got platinum in it, we're going to sell all of that. Unfortunately, the economists have this problem called inelastic pricing. Mm-hmm. That if you flood the market with a bunch of stuff, the cost kind of comes down, drops out. So there again, I think the space cadets that want to show and demonstrate that we're going to do great things in low Earth orbit and manufacturing and recovering asteroids just haven't thought through it. And in the studies I participated in, there's very few things there other than tourism, pharmaceuticals, and maybe some fiber optic and similar devices like that will have value.
What about climate crisis? Can we produce energy there and not pollute our environment and still live? Will that be more valuable than any of this? And can we do that there?
Well, I think that certainly is possible, but given the price of assembling solar orbiting power stations and then beaming that back down to the ground, you incur a lot of risk. Just last week, the Europeans had a fusion reactor that ran for 5 seconds. They're getting very close.
Yes.
When fusion comes online, I think that's going to be a game changer for everything. It'll be the Star Trek economy,
right?
Where everything will be free because the power to make it is free, and power, and whether it's going into the formulation of a metal or construction of an object or even running the conveyor belt on the production line, power is a major cost of putting everything together.
Yes.
And once power is free, we're going to see a change in how the economy is developed.
So you think that we will have fusion technology cheaper and faster than we will be able to send and set up solar stations in low Earth orbit and beam electricity down?
I believe that's true.
Interesting. Yeah, and I never thought of pharmaceuticals, fiber optics. Yes, I can see how that can drive Wall Street. Pharmaceuticals is very, very interesting that you bring that up, that if you can innovate there. And you were talking about some of the innovations, osteoporosis, you talked about fluids in the body. I know telemedicine came through, NASA as well. What else are you seeing coming down from research in space medicine that's being applied?
I think one of the most
right now.
One of the most interesting things, and probably the one that's closest to my personal interest, is macular degeneration. Is a disease that affects the eye. My mom has it. Just over time, you start to lose your eyesight because the rods and cones are decaying back in your retina. On the space station right now, there's a company that's doing research to develop a little patch of material. And that patch would be placed behind your retina and would replace the signal carrying capabilities of the biological systems that are there. But that patch is a layered material, and it can only be made in 0G because, again, convection on the ground or gravity would disrupt it, and you wouldn't get these even layers that you need in order to serve as a signal transmission media. So something like that is going to be very useful and help millions of people if it can be worked on. And I'm just looking forward to those kinds of discoveries. In the past, we have learned that going to space and taking gravity out of the equation, we can learn about how some process works perhaps a little better. And with that knowledge, we've actually been able to come back down to the ground and fix the problem that we had previously because we were able to understand the physics of the problem better. So there's still going to be that kind of basic research that's going on. The space station will be around till 2030. We have a number of commercial outfits that are getting ready to fly. And I think they'll do that basic research. And I suspect that will be mostly focused on pharmaceutical kinds of efforts that are just difficult to do in a 1G field.
Very interesting. Never thought of it that way. That's a very, very interesting insight. Huh. Who do you think we should talk to next? Who can talk to us more about pharmaceutical research in space?
I may have to get back to you on that.
Sure.
But there are certainly a number of experts, certainly down at NASA and at KBR Wiley and folks like that. University of Texas Medical Branch is a place where I would certainly go look. They have a number of programs with the Johnson Space Center where their medical folks and bioengineering folks work together with the Space Center people to develop new technologies and mitigations for humans flying in space.
Yeah, we would appreciate, anyone you could recommend, and just not pharma research, but people you think will be good people to talk to just to learn about this. But this has been really, really very helpful just to understand space exploration from an engineer's perspective. We have talked about it from many different perspectives. It was a very refreshing way to hear the logical way of how we are doing this. So thank you for your time. Anthony Tillman, any parting comments?
Oh, well, I wish we had 3 hours to talk to you instead of 1. But again, thank you for taking the time to come on and make the appearance today.
Sure.
I'll sort of parrot that. Yeah, thank you very much for coming on. I really appreciate getting the. I feel like it's almost like the inside scoop. You've been dealing with this for so long that you know all the shortcuts, and we're on the learning curve, and you've already got us. So you're getting us there quicker. So I really appreciate hearing from you. Like Anthony said, I wish we had longer. But this is a great discussion, and I really appreciate you coming on.
Well, thank you all for the opportunity. It's been a pleasure and very good questions. Really enjoyed talking with you.
Thank you so much.